Okay, now we can apply our mathematical tool developed in the previous lectures to an very simple economic model. So we can consider a microeconomic model in which we have supply and demand. The first equation for our model will be QD, which is the quantity demanded for some possible good or service. This is, we can assume this is our hypothesis, that we can write this demand in the following way: A0 minus A1P plus A2Y. P is the price of the good we are considering. So for instance, we know from economic theory that if price grows, then the quantity demanded goes down. Y is the income. We know that if income grows normally, also the quantity demanded quantity tends to increase. A0 is given by every variable other than price and income that can explain the demand. So for instance, wealth, interest rate, tastes, and so on and so forth. So this is our first equation of our model. Our second equation is the supply of these goods, supplied by firms. So we can write this equation 2, as B0 plus B1P minus B2W. P is prices, so represents prices. If prices increase, firms have incentive to increase the offered quantity. W is wage, represents wages or cost for our firm. So if costs increase, we have a decrease in supply. P0 represents all variables other than prices and wages, which can explain the supply. Finally, we have the so-called equilibrium equation, which is QS equal to QD, and this is our third equation. What does it mean? It means in equilibrium the demand must be equal to supply. So we have three equations, and in these three equations we have three endogenous equations and three endogenous variables, because endogenous variables are variables determined in the model and are demand QD, supply QS, and prices, equilibrium price P. All our other variables are exogenous variables in the system. So A0, Y, B0, and W are exogenous because are given in this problem. In order to simplify notation, we can assume that the equilibrium quantity is given by Q star. This is the quantity in which the demand is equal to this supply. So we can write this system in the following way: Q star equal to A0 minus A1 P star. P star is the equilibrium price, Q star is the equilibrium quantity, plus A2 times income. Then we have Q star, which is the supply, equal to B0 plus B1 P star again, minus B2W. And this is our economic system, in which we have two endogenous variables, Q star and P star, and two equations. And we need to solve this system. In order to solve this system, we can rewrite the system putting on the left hand side the endogenous variable, so Q star minus or plus A1 P star equal to A0 plus A2y, and this is the first equation. Then we have the second equation, Q star minus B1 P star equal to B0 minus B2 W. We can write this system in matrix form, and it's not so difficult, because we can consider matrix of coefficient A, which is equal to, it's better to delete this picture. We can write matrix A as defined as 1 A1 1 minus B1. This is the coefficient of these are the coefficients of the endogenous variables in our system. Then we have vector consisting of the two endogenous variables Q star, P star. Then we have the matrix B defined as 1 0 A2 0 0 1 0 minus B2. These are the coefficients of exogenous variables. The exogenous variable is the vector x given by A0, B0, y, and W. We can write in a more compact form our system we are trying to solve as AY equal to BX. Because if we multiply B times X, we get the right hand side of the system. Now, in order to solve this system, we know that we can compute Y as the inverse of matrix A, the matrix of coefficients of endogenous variables, B times X. So we need to compute as first step the inverse of matrix A. In order to compute the inverse of matrix A, we need to compute as first step the determinant of matrix A. This is very simple because it's a 2 by 2 matrix, and the determinant is minus B1 minus A1. In order to solve this system, what is required is that the determinant of A is other than 0, so B1 other than A1. Because if the determinant is equal to 0, this system has no solution or infinite solutions. We can write again matrix A. Matrix A is given by 1, A1, 1 minus B1. As first step, we need to consider matrix of cofactor, which is given. Cofactor of 1 is equal to minus B1. The cofactor of A1 is minus 1 because the position is 1, 3, 1, 2, so the sum is also. So very simple. Need to relate. So matrix A is given by 1, A1, 1 minus B1. So we need to consider matrix of cofactor. The cofactor 1 is equal to minus B1. The cofactor of A1 is given by -1 because the position is 1, 3, or 1, 2, so the sum is equal to 3. Then we have the cofactor of 1, which is equal to -A1, because also in this case the position is 1, 2, so the sum is 3, and -1 to the power of 3 is equal to -1, so we have to change the sign. Finally, the cofactor of -B2 is equal to 1. The joint matrix is given by, I remember, the transpose of the cofactor matrix, so is equal to -B1, -1, minus A1, 1. Inverse. In order to get the inverse of matrix A, we need to multiply 1 over the determinant of matrix A for the adjoint matrix A plus. So finally we have that the inverse is equal to matrix A, it's better to write in this space, is equal to B1 times B1 plus A1, A1 over B1 plus A1, then we have 1 over B1 plus A1, and minus 1 over B1 over plus A1. This is the inverse of matrix A. Now we need to compute the product between A to the power of -1 and vector B. This product is possible because the number of columns of the first matrix is equal to the number of rows of the second matrix. So the product will be given by B1 over B1 plus A1, A1 over B1 plus A1 again, A2 B1 over B1 plus A1, and finally minus B2 A1 over B1 plus A1. The second row will be given by one over B1 plus A1 we are sure. Then we have -1 over B1 plus A1, A2 over B1 plus A1, and finally B2 over B1 plus A1. And this product. So the final solution of our system will be the following. Q star, which is the first endogenous variable, will be equal, because the final solution, remember, is y equal to a minus 1b times x. So the final solution will be Q star equal to b1 over b1 plus a1 a0 plus a1 over b1 plus a1 b0. Then we have plus a2 b2 over b1 plus a1 y plus again minus b2 a1 over b1 plus a1 multiplied by the last exogenous variable, which is w. And this is the first endogenous variable in function of all the exogenous variables. Then we have p star, which will be equal to 1 over B1 plus A1 A0 minus 1 over B1 plus A1 B0 plus A2 over B1 plus A1 Y, and finally plus B2 over B1 plus A1 for the last exogenous variable. This is the reduced form model because we have each one of the two endogenous variable Q star or P star in function of the two of all the other exogenous variables we have in the system. We can see that, for instance, the effect of an increase of A0 on the equilibrium value of Q star and P star is positive. So we can see that if there is, for instance, an increase in the wealth of households, we have an increase in Q star, but also an increase in prices. If we have, for instance, an increase in income, we have two effects: an increase in Q star, in the equilibrium quantity, but also an increase in price. We want to show that if we do the two pictures in which we have Q and P, this is the quantity, the demand for each price, and this is supply for each price. Or if we look at the reduced form model, we can assume there is an increase in income. An increase in income may be represented by a shift up of the demand, whose final results is an increase in price and an increase in quantity, as you can see in the system. But if you look at the reduced form system, we can compute the increase in quantity and in price we can get. In the same way, if we have a change in other exogenous variables. Thank you.